So when we look at Jupiter, we see a lot of structure that looks very similar to the Earth. We can see storms, we see cyclones, we see anticyclones, and these sort of storms and weather systems that we see on Earth are very similar and they're happening on Jupiter. Fluid mechanics is hopefully the same everywhere in the universe, but Jupiter and Earth are very different. Jupiter is much bigger, it rotates a lot faster, they're made of different material, and Jupiter's much further away from the Sun than the Earth is. The quasi-biennial oscillation, or the QBO, on Earth is an equatorial phenomenon in the stratosphere where the winds are changing direction approximately every 2 years. Depending on which phase the QBO is in, eastward or westward, the temperature signal corresponds to that. So it's warmer in the eastward phase and cooler in the westward phase. It's been shown that it can actually be a barrier to transport of aerosols across the equator and has been linked to the frequency and the formation of hurricanes in the Atlantic and the Pacific Ocean. The long-term scales on Earth's climate is something that we're very interested in, and how that applies to other planets' atmospheres is really why we're studying Earth and Jupiter. The quasi-quadrennial oscillation in Jupiter's stratosphere is a temperature signal that we see in the equator, where we see the temperature get warmer and cooler approximately every 4 Earth years. We used a general circulation model where we focused on simulating the effects of small-scale waves produced from convection in Jupiter's equatorial region to simulate the QQO. The waves propagate upwards from the clouds and force the winds in the stratosphere to change direction, going from eastward to westward approximately every 4 years. Our model was able to reproduce the behavior of the QQO, but was also able to reproduce temperatures from the observations, and both of those together give us a lot of confidence that our model is very accurate in what's driving the QQO. The outer planets serve as a laboratory for understanding atmospheric physics under very different conditions that are present on the Earth. Understanding how their atmospheres change and evolve and their climates can give us insight into any planetary atmosphere.